Welcome to Across the Globe. Today we will learn about advanced Go programming. To achieve expertise in advanced Go programming, one must thoroughly grasp intricate features like concurrency, interfaces, and performance optimization. Prior comprehension of fundamental Go concepts is crucial for navigating through these advanced areas. For instance, understanding goroutines and channels in concurrency is essential for writing high-performance and scalable applications. Similarly, a strong foundation in interfaces aids in designing flexible and extensible code. Lastly, optimizing performance requires knowledge of profiling tools and techniques to enhance the efficiency of applications. Thus, a comprehensive understanding of basic concepts serves as the stepping stone towards mastering advanced Go programming. Concurrency in Go is facilitated using goroutines and channels. Goroutines are lightweight threads that enable functions to execute concurrently. Channels, on the other hand, provide a means for goroutines to communicate with each other and synchronize their actions. This built-in support for concurrency allows Go programs to efficiently utilize multiple cores and maximize performance. In comparison, Python also offers concurrency support through threading. Like goroutines, threads in Python allow functions to run concurrently. By creating a new thread and specifying the target function along with its arguments, developers can achieve parallelism in Python programs. The example given demonstrates how a message can be printed concurrently using a thread in Python. In Go, interfaces define behaviors without implementation details. They facilitate creating modular and extensible code. An interface specifies a set of methods that a type must implement to conform to that interface. Implementing a Go interface requires defining all methods included in the interface for the type. While a struct in Go provides a way to define data, interfaces define behavior. Using interfaces allows code to be more flexible, enabling different struct types to satisfy the same set of behaviors. For instance, a shape interface in Go may define a method for calculating the area. Different shapes like circle, triangle, or square can implement this interface by defining their respective area calculation methods. By leveraging interfaces, applications can be easily extended to accommodate new shapes without changing existing code. This approach enhances code reusability and maintains a clean design structure. Performance optimization in software development is critical for high-performance applications. Go, for instance, provides various tools and techniques for this purpose, including profilers for identifying bottlenecks and the implementation of efficient data structures and algorithms. It is essential to analyze and optimize code to ensure optimal performance. For instance, in Python, one can measure the execution time of code using the time module. By capturing the start and end times of a code segment, the execution time can be calculated by subtracting the start time from the end time. This allows developers to identify code segments that may need optimization for improved performance in high-load scenarios. Advanced Go programming is like being able to speak a foreign language fluently and effortlessly, allowing you to communicate complex ideas with precision and clarity. It's like having a set of finely tuned musical instruments that you can play expertly, creating beautiful and harmonious compositions. Advanced Go programming is like mastering a martial art where you can anticipate your opponent's moves and react quickly and effectively in any situation. It's like being a master chef who can combine ingredients in creative ways to create mouth-watering dishes that delight the senses. Advanced Go programming is like having a superpower that allows you to manipulate data and algorithms with ease, solving complex problems with elegant solutions. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The Advanced Go Programming Analogy function within this Go program showcases various scenarios to demonstrate the concept of advanced Go programming through analogies. 1. Fluent communication. The analogy of speaking multiple languages fluently like a master linguist is presented by joining elements from a slice of languages and outputting a descriptive example. 2. Expert musicianship. The analogy of playing various musical instruments expertly is illustrated by joining musical instruments from a slice and displaying a descriptive example. 3. Martial arts mastery. The analogy of reacting to opponents' moves like a martial arts master is depicted by joining opponent moves from a slice and outputting a descriptive example. 4. Culinary creativity. The analogy of creating culinary masterpieces with unique ingredients is shown by joining different ingredients from a slice and displaying a descriptive example. 5. Data manipulation superpowers. The analogy of effortlessly solving complex problems with elegant data structures is portrayed by joining various data structures from a slice and outputting a descriptive example. The main function calls advanced Go programming analogy to print out these analogies, allowing the user to understand advanced Go programming through diverse real-world examples. In the realm of industrial applications, advanced Go programming can be seen in the development of high-performance web servers and microservices. The efficient concurrency model and powerful standard library of Go make it an excellent choice for building scalable and reliable server-side applications. For example, a popular real-world application of advanced Go programming is in the creation of distributed systems. Companies like Google, Uber, and Dropbox leverage Go's capabilities to build robust distributed systems that handle large volumes of data and traffic efficiently. Go's built-in support for concurrency primitives such as goroutines and channels enables developers to write concurrent, asynchronous code that can handle thousands of requests simultaneously. Another industrial application of advanced Go programming is in cloud-native development. The cloud-native ecosystem relies on technologies like Kubernetes, Docker, and microservices architecture to build scalable and resilient cloud applications. Go's simplicity, performance, and support for building microservices make it a preferred language for developing cloud-native applications. Companies like Netflix, SoundCloud, and Twitter use Go to power their cloud-based services and applications. In conclusion, advanced Go programming plays a crucial role in industrial applications such as distributed systems, cloud-native development, and high-performance web servers. By harnessing Go's concurrency model, performance, and efficiency, developers can create robust, scalable, and reliable applications that meet the demands of modern enterprises. Across the globe, keep learning, stay curious, and I'll catch you in the next video.